Okay. So good morning and good evening, team. For the recording sake, welcome back. Session 2 of Gen AI Engineering, Agentic AI. The more people are joining in. So let's get started with a quick recap of what we discussed yesterday, and then we move forward with a couple of topics that would lay foundation for our training. So basically, yesterday we talked about how the Gen AI has evolved, and then what is a large language model, what is ChatGPT application versus a model, LLM, what are the features of an LLM model, what are domain specific, what are different types of LLMs like text to image, text to audio, text to video, image recognition, audio recognition, and then we talked about the size of the LLMs, basically the parameters that's trained on, which would impact the complexity of the model, and then choosing which model is right, and also the domain specific LLMs for each of the use case, right? And then so these are all the things that we talked about yesterday, and then there are different vendors, so different platforms. We looked at Google Vertex Model Garden, right, yesterday. Not here. Let it open here. Yeah, we looked at OpenAI models. We looked at Model Garden for Vertex. Same thing you would also have in the Bedrock. If you go to Bedrock and look at so Amazon Bedrock, you would have the same Titan models that you could look at. So if I go to Amazon Bedrock, that's where we build our RAG architecture or our agentic applications. So in the Bedrock, I guess Reinvent, they're coming up with a new platform. I heard yesterday, I haven't explored it yet, but um, uh, currently we're still using the Bedrock for this. Earlier, SageMaker was there to do the machine learning, but for AI, it's the Bedrock now. If you look at Bedrock and go to model catalog here, so in Google, they call it Model Garden. Here, they call it model catalog. So every platform has similar features. Once you go through this training, right, you understand all the concepts, you know how things are connected. Now, switching between platforms is just like this. If you go to one platform, the name changes from the other, but theoretically or practically, you would do the same thing to build the application. It's just that how it is implemented is different. Okay. Same like there you have Google Model Garden. Here you have Model Catalog. So same thing you see Bedrock Marketplace. There are 175 models here. You can see by Amazon. Amazon has two series, Nova and Titan. Okay, so they have their own models hosted you can use. Again, we looked at Mistral yesterday on Google. Also here, also you have Mistral, Claude from Anthropic. All the models from the Anthropic you can see here. Meta Llama you can see here, right? And these are Amazon Nova, Nova Premier, Son, Canvas, all of these models. You can filter based on provider. Is it AI, 21 Labs, Amazon, Anthropic, Cambia, Cohere, DeepSeek, all of this. Or you can look at modality. So modality, is it the audio or is it embedding? Is it image? Is it multimodal? Speech, text vision, video. So if you go to video, it has two, Nova Reel. It's basically the same thing. I don't know why it's showing twice. So Nova Reel is its video. And so if you want to go image, Titan image generator. It's one. stable image conversion, creative upscale. So these are all different models that Amazon has hosted. So any of these you can use when you are building your AI applications, either it is RAG or it is um, Agentic. You can use these models on the platforms. Same thing Azure also has in the AI Foundry. So these are the, if you go to other platforms, say these are three hyperscalers anyway, they have their own models, they have their own platform. Plus they can use hosted models from Anthropic, OpenAI, like GPT models, Cohere, DeepSeek, whatever. There are hundreds of thousands of models available that can be used. If it is hosted, it is easier to use. Even if it is not, you can still use it connecting using an API to call any of the models. Okay. And then you have data engineering, data platforms, basically Databricks and Snowflake. So Databricks has DBRX is their own model. However, yeah, I don't see they are aggressively pushing that into the developing models on their own. However, they're coming up with their platform. I mean, they have released a platform called Agentbricks, um, which can to build the same thing like applications. Even before they had ML Flow and Mosaic ML, now it is all combined into one platform called Agentbricks, where you can build agents and deploy agents and do everything within Databricks. Snowflake has similar thing called Cortex, where they have their own AI development and building using the models and all of that. So these are the top the hyperscalers and the data platforms. So other than that, you see the independent providers, right? The OpenAI, Anthropic. These are the actual providers of the models mostly. They don't process any data, or they don't have platform like this, but they are like more providing the models for building this. OpenAI also has come up with a agent kit, similar thing again to build the agentic AI. So there are other applications or tools or products, you can say, like N8N, Zapier, Make.com. So these products are also used to build the AI-based workflow automations. So this is all the canvas that you have, different products, tools that you can use for building the applications. Okay, so don't get too overwhelmed as we progress, as we start using these platforms. You will get to know, you will get very comfortable with all of these things. Okay, so what you have to remember from this, there are LLM models like independent uh, units, right, where it's like a service where you can call that service and it would give a response. That is the LLM model. Who's providing this model? There are many vendors. Which vendors? OpenAI, Anthropic, Cohere, DeepSeek, Bedrock, Google. All of these are vendors or providers who provide the LLM models. Then, using that model, you have to build applications. So there are platforms that will help you to build applications. Again, if you can build those applications on Google Vertex AI Studio, Amazon Bedrock, or the new one, Cairo, or whatever that is, we'll see, Azure AI Foundry, or Databricks, or Snowflake, or you just go open source like we will be doing it without, I mean, some with platforms, some without platforms. Just Google Colab or VS Code, write your own Python code and use these models to build your application libraries and use this application. Then fourth, there are other platforms like Langflow, right? So, or Langflow is a UI based, which is data stacks company owned by IBM. it's a UI based drag and drop thing where you can build your own agentic AI applications. Again, similar to this, you will find the models that you can use there to build the applications. Okay, line flow. And then, as I said, there are workflow automation tools like N8N, Zapier, Make.com, and all of this. So that's the whole canvas for the AI. Good. Any questions? No questions? Okay. So that's what we talked about, right, yesterday. Now we are moving on to the next thing. So we'll talk about prompt engineering, and then we'll talk about the uh, RAG architecture. What is RAG and why we have to do that? Very brief introductions. So you have all worked with ChatGPT, and then it's like you ask a question, it gives you an answer, right? So what happens between that ChatGPT? We said there is an LLM model sitting there behind, and this is a wrapper or front end UI. As a that's as a chat window. Basically, you type the chat and it takes the question and gives it to the LLM model, and then the model gives you response back. So how do you communicate? What type of questions you ask and how do you get your response? Of course, again, in the last 2-3 years, the models have matured so much. But earlier stages, a lot was dependent on how you ask the question. Even now it is, but it's the models are matured to write their own prompts also if you request them. But what you ask a model, it will impact what the model gives you as a response, how you ask basically. So as a model, model is same like a baby, right? You're training a baby or you're asking a baby to learn something. So you have to give very specific step-by-step instructions for it to understand your problem, your question, and then respond it. If your question is vague, your prompt is vague, you get a very vague answer from the model. So that is called a prompt engineering. Basically, structuring your prompt, making sure you are asking in a particular pattern or a structure that the model will understand and respond accurately. Okay, so that's all about prompt engineering. So that's what we talk about. Okay, so this will come to RAG will come from here. So let me share my screen. So prompt engineering. So how do you think? Give me an example of why a good prompt is important. You must have you must have been interacting with ChatGPT a lot, right? Give me some examples of, do you get everything in the moment you ask a question, or how do you ask a question?
I mean, to reach that desirable output, we ask series of questions like based on whatever. Let's say I'm asking to a very basic one like uh, type an email, some formal email, and that ChatGPT didn't get that context, like who I am. Let's say I'm asking to write something to respond my manager or someone. So there is a two ways. So since I have not given the context, it might ask like I'm responding to my juniors. So better I need to set that context. Okay, I'm writing to my manager, so it will write a different. It will choose different word, different type of text to write that email. So proper setting context is important. Otherwise, we get a different kind of answer. So for the same question, if I'm asking for manager, it will write different. If I'm asking for my juniors, it will write different. Same email response.
Right. Great, great. So have you, when you are talking, right, you said you want to write, yeah, or you want to modify resume for your, say, some job application that you're doing, or you want to search for a vacation, or you're um, or let's say you are writing a um, LinkedIn post. Let's say three different scenarios, right? So in these scenarios, what do you ask the model? You just write your question, or what kind? How do you think you should approach three different scenarios? So do you just put the question and let a model answer you, or do you do anything specific?
I'll tell like I'm just going to write for the LinkedIn post or something. I'll just give that context like
Mm-hmm.
so that I'll understand like a style of writing or what need to be posted on LinkedIn and what need to be go like in email or what need to be.
Exactly.
The main thing
Yeah.
I'm thinking like it should be the context. So you should
Right.
know about like where what kind of answers it should be.
Right. Great. Okay. Awesome. All good. Good answers. So basically, when you do a prompt, as Satya was saying, you need to have a context. You need to give a context. You need to give set a tone. Um, so what you are trying to achieve, exactly, what is the style, what is the tone, how much should be the response, how it should structure the response, what all it should include in the response, should it be exhaustive or should it be summarized, should be bullet points, right? So all of these things would matter. Now, creating effective input prompts to get the desired outputs from generative models. That's all the prompt engineering is about. Basically, there was a lot of focus on prompt engineering in the 2024, last year, but over 2025 it slowly phased out, or the focus has died down. It doesn't mean that prompt engineering has become less important. It just means that the models have evolved to alternatively write their own prompt uh, for them to answer. So basically it became a two-step process instead of a one-step process. Initially, you used to write a prompt yourself. You need to curate the prompt yourself and then ask the model. Now, what you do is you take your rough or draft prompt, whatever, like you just throw all the everything at a model. Then, before answering that, you would ask the models to first generate a prompt for the model itself. So as a first step, you ask the model to give a prompt. You take the prompt and then ask the model back to generate the response. So most of this work has been now taken over by the models itself to structure your prompts when you give the draft or rough input. Even if you, and then there are some third party tools that have come up. Again, you put the same draft. I'll show you. There's something called feeddo.com, one of those the tools, applications, or the products that would create a prompt, and then they have come up with various templates for structuring all of that. But nevertheless, it does not decrease or reduce the importance of prompt engineering. It's just that you are now have a better way of doing it, or better tools or the models itself, you can AI itself you can use to do most of your work, even for the prompt engineering. But you should know what prompt engineering about is, what you should know, why you should put all of this in that. So well-designed prompts improve the quality, accuracy, and relevancy of the results. Let me take this put. Now, let's say you're going to a restaurant and then you want to order. If you say, bring me food, so you're going there to get the food. So bring me food would make like it's chef's choice, right? So you bring me whatever you want to bring, I will eat. So he can bring anything. You might be a vegan, vegetarian. He might bring you a meat dish, right? Or you say surprise me. He could get you seafood. You might be allergic to it, right? Now that same thing you're doing, like doing a prompt to your model. A clear prompt would say, hey, give me a vegetarian curry, like mixed veg curry or some veg vegan curry, spicy and using less oil. Most of the times, if you see, just like your chat GPT asks you back, do you want to do this? Do you want to add this? Um, the serving person, he would also ask you a question, what is the spice level, right? That you want to, and different options that are available. Do you want it in a small or a big one kind of a thing? Um, so these are the nuances or fine instructions that you need to get you exactly what you want. So the same thing here uh, in the prompt also. So you would give a clear structure or inputs of what you are expecting from the model, right? So just like when you're ordering, you're being very specific what you want, how much you want, and everything. In the model also, you will say what you want, what should be the response, what is the tone, what exactly do you prefer, in this format do you prefer. So all of that, you will write. Say you're writing a code just to retrieve data from a database. I'm just giving an example. So a vague prompt, you can say, hey, generate a code to get data from database. Now, what is missing in this? What are the additional fine instructions you should be adding? Or what does the model respond if you give this prompt? Anyone? So my prompt says, write a code to retrieve data from database. One guy, just give it a shot. There's no right or wrong
Okay.
answer.
First of all, table
So it
is
just
missing in the prompt.
Nishi, go ahead.
Yes, sir. In this, the table is missing in the prompt. Means which specific table we need to give.
Table. Okay. What else?
Table. Then like columns and names as well. If any filter condition is there to fine tune the result.
Okay. What else? Where is the table?
In the database, which
it,
schema, which
Which
database name,
database?
which
Yeah.
database we need to
You
give.
don't know which database, right? So,
Yes,
okay,
correct.
database name. What type of database?
It's a tab. It's a relational database.
What relational database? There are so many,
Yes, sir.
SQL, Oracle,
right? So,
MySQL.
yeah. What is the type of, which kind of database? What is the database? Um, okay. And what language you want to write the code? You want in Java, Python, JavaScript, C hash, .NET? It doesn't know which language do you prefer to write that code in, right? So in one line, just say, write me a code to get data from database. So right now you said so many things are missing. So how would the model know? It would just start giving you generic templates. Now that you will have to go through various iterations to come up, to help you with the exact one. Now, a clear prompt would be like generate. I know you must have done this. I do this, that I put generate a code snippet in Python. So I will tell it you should write in Python. So I get the Python code to get data, to read data from a SQL Server database. Okay. And then I can give database table names, or I don't want to give it, because you have to be very cautious when working with the models, because you don't want to give out any company specific or confidential information. It's okay to some extent just to give the names, because you're not giving out any data, or you're not giving out any server URLs or connections. So always make sure you don't copy paste any of the data from the company. Like if it has a URL string, connection strings like database name, database connections, right? Host port and all of that, or actual data of the company. These two things you should be very, very particular about. Make sure you don't expose this or you don't give it to any model anywhere. Rather, you should just get generic code, take it in your environment, and then add your information, the configuration parameters. So it will give you the template. It will not ask you. So database table names should be okay, generic, because think of, if this information is given to somebody, would they be able to break in, right? Just with table database name is not very but it is for some people. They don't even want to share that. It's still confidential, but maybe medium risk. But URLs data is very, very high risk. You should never give it out. So you give this kind of prompt to read data from the database. So you say, I want it in Python, I want it from SQL Server, this is the database name or table name, and then make it generic so that I should be able to pass any table name. Make it generic. I should add different methods. One, if I give a table name, it should give all the data from the table. Number two, I should be able to pass just a SQL query. It should execute and give me the data back. Okay. And number three, any delete or insert, give me a separate method to insert data into the table. Give me a date table, give me a method to update data or upsert data. So you can give in structure, in bullet points, what all you need. So it will give you specific code to generate, it will give you each method separately, and then you can implement that. Right. So that is how a clear prompt will help the model to respond. Okay. Any questions? So there are some examples where of course I will share this deck to you guys. You can go read out and to give you a more clear understanding. I'll just go through a few of them here, but when I share the deck, you will have more of this. As Satya earlier mentioned, writing a client email. Write an email to a client, Acme Corp, regarding a 2-day shipping delay. So the model will give you a template, okay? That there is a 2-day shipping delay, and then obviously you need to apologize or give a formal tone. Even apology, a personal apology letter is different from a professional, right? Coming from a company, right? And it also depends on who you are writing to on the other side. Nature of the deal, nature of the delay, impact of the delay. So all of this will go into writing, structuring that email. So a good prompt is, you are an account manager, which means this is called role play. You are assigning a role to the GPT. I think I'm sure you must have done all of this, all of you must have done this. You are assigning a role to your model, LLM model, because once you do that, it will give more specific answers based on that role. If it is an account manager, it will only look at trained data based on account manager scope. So you will get more refined answers by using the role. You are a sports manager is completely different from account manager. So the entire domain is different. So it will only look into the information that it has in that domain to answer the questions or to generate the answers. Now draft a polite 120 to 150 word email. So you're also giving how much your email size should be, versus in the first one, if you just say email, it might generate a 3-4 pager, or it might just generate a 2 or 3 line because you have not given the instruction. So here you are also specifying how much the email should be, 120 to 150 words email to the client, explaining this is the client and this is the shipping delay. And then you're asking to include the cause, why the delay has happened, versus in the first prompt, it is generic. So it will assume something. Okay. Now, if this is the prompt, same prompt, right? So I asked, if you ask, right, what it would do, it said due to, it doesn't know what it is, so it left it open. Supply chain disruptions, logistic challenges, right? And then you would have to again go back and add all of this. Instead, if you say supply chain disruptions here in the prompt, okay, include a cause, supply chain, new ETA, when it will be delivered, and then a 10% discount code for future orders, and clear CTA to confirm. So all of this, it will help you to get more structured email than this generic email. So this is how you get more information for the model to give you more specific answers, right? Let's take a few more examples. A product spec you want to build, make a PRD product spec for a chatbot. It'll give you generic pages and pages. Now here you are giving a one pager. You say you just want a one pager. You don't want 50, 60 pages of all the specifications. A support chatbot for a fintech app. It says here it is simple chatbot, but here you're talking about a fintech application, a chatbot for fintech application, specific domains. Now you should have these sections: problem, goals, scope, and what it should include in each of these, non-goals, metrics, risks, timelines, output as in the markdown format. Basically, and then coding, if you want, write a code to clean data. Then here you want saying Python or pandas function. You want to also put a function name, which would take a data frame that trims strings, parses order date as UTC, fills missing price with median per region, and drop duplicates by order ID. So it will convert all of this requirements or pseudocode into the actual code using Python here, very clear. So this is all you want to include in the cleaning the data. Include docstring and one PyTest example. So you're also including a docstring basically to explain what that method does, and also a test, PyTest, one scenario, one test case you want to generate using PyTest. As I was talking about SQL, right? Give SQL for monthly sales. So what database, what tables, what monthly sales, by month, what is the date, what are the columns. So all of that you have to do. Of course, there are some, if you go to, like I was talking about Databricks, there is something called the most popular use case in enterprise is text to SQL, which means you can type a prompt. Your application, AI application, should automatically convert that into a SQL, and then run the SQL against your database, get the results in a tabular format, pass it to a BI or another Python function to generate a visualization and display the visualization. Just like, say, monthly sales, it should directly display a chart or a pie diagram for monthly sales. But here, it's not very specific, right? In Databricks, you have the Genie app or the tool application where you add all your required tables into that workspace, and then the model will understand what data is there in all of those tables based on the metadata, the tags, and then it will convert your data into SQL. It will write the SQL, it will write all tables, columns, joins, what it needs based on your SQL, and then it will generate the answers. So same thing, if you want to write a SQL, so it has to have more information to get in from the tables. So it can generate the SQL, but it will get all of this. This is writing this, giving more information to generate that SQL. analyze the CSV. So basically, yeah, same thing. I have given a lot of information, to go through with prompt examples. But yeah, it's just for reading's sake. Long story short, why and prompt is important. And we are here. As I told you, there are third-party applications. So you can also ask the model itself to fine-tune your prompt for the LLM model. Or you can go to some third-party applications like this. If you see feeddo.com, AI prompt generator. So here, it's just a small application that will help you to write prompts. So you can write your vague prompt here. Let's say generate a SQL for getting information from MySQL database for sales data on a quarterly or monthly basis. So generate. You can take the same prompt and ask the model, or you can use this and ask to generate. So when you ask to generate, so this is the more structured prompt that it has generated. Okay. See, you are a knowledgeable SQL expert. You are giving it a role, the model, with extensive experience in generating queries from various databases, particularly MySQL. Your specialty lies in creating efficient and effective SQL statement that extract meaningful insights from sales data. Your task is to create and allowing for analysis on either a quarterly or monthly basis. Here are the specific details to consider for this query. So now you fill up, what database you want, what table you want, what is the date column, what is the sales amount column, because this is what it needs to generate the SQL for that, right? So you give database name, table name, date column, sales amount column, grouping interval, you want monthly or quarterly. Now you're giving a more instruction like query should be structured in a clear and efficient manner with proper use of aggregation functions and grouping clauses to facilitate the desired analysis. Be sure to include appropriate filtering conditions if necessary, such as date ranges or specific product categories to ensure the results are relevant to the analysis. Example output could look like this for monthly data. You are giving I'll talk about this. Remember this. Why you're giving this example? What is it called in the technical terms, right? In a strategy, you're giving an example here for monthly data. It should look like this. For quarterly data, it should look like this. You can say, hey, if I'm doing all of this, why would I need LLM? But yes, it's giving just one example. But you can skip this. You can just give the table and also it can also generate that. Ensure that SQL syntax is accurate and compatible with the MySQL version being used. Avoid using deprecated functions, methods that may lead to error in execution. So this is much more elaborate and clear instructions to the model to generate versus this one-liner. Now in this, you fill up your database table column, sales amount column, and then you copy this prompt and you add it to the your model to generate the response. Okay, so you are also giving date column, what is the date format, kind of a thing. Got it? Questions? And they have also come up with, there's some templates. This is not what you say is industry standard. This is just like their way of categorizing different types of prompts into the templates. There is the frameworks basically. Role, action, context, explanation, K prompt, A prompt, all of this. Roses prompt, role, objective, scenario, expected solution. I don't see very very much, kind of very fine-tuned response from use of this, but most standard should be good enough for you. But the more you add here, the more specific your output or the prompt becomes. Yes, sir. Somebody had a question.
Hey, Harun, it's Neeraj here.
Yeah, Neil.
Hey, one thing that I have noticed for this code generation piece, whether it is even from Cloud, that if there is something that needs to be built from scratch, it does good job. But when we are refactoring an existing code, that's where it makes a lot of mistakes, even simple things like data mismatch, right? The data type mismatch. So my question is like, is it something that you have also experienced that, or maybe it's just my prompting needs some changes?
Well, it is code generation is complex because, as I said, the models are generic, right? And it also first depends on which model you are using, generic versus code generation specific. If you take OpenAI or any other, in the features, it prefers, right, the code generation as a feature, which is more fine-tuned for code generation. If you're using GitHub Copilot or any of the code specific, it would help more. But nevertheless, yes, I have also faced when generating the code, sometimes it duplicates because we are doing multiple iterations. When we see something is missing, you add that into the prompt, you missed this, it would say, yes, sorry, I missed this. It will try to add that, but then it would miss something else at the top, which we will not notice. Or sometimes if there is a duplicate, it says it has removed it, but you still see it in the code output that it is a duplicate code that is generated. So yes, I have also seen there are some issues. That's why we said, right, AI is not there yet to blindly just give commands and then everything magically happens. There is still human in the loop who understands what it is doing, who has monitors and does an oversight, review, fix things. It can only help you accelerate, give you a template, boilerplate, all of that quickly, so that you don't have to worry too much about it. Simple example is, I have a JSON response coming from an API. Okay, I want to parse that JSON and print out each attribute. That's so simple. Now, how much boilerplate code you would need in Java? So if you just put it in the model, right, it would give you the modeling classes, just like based on the response output, 2 or 3 classes, Java classes. Then it will give you a Pojo class to parse each. Then it will give you the loops to go through each of that to print it. Everything in less than a minute. If you have to actually code all of that manually, it would easily take you half a day. Right? So those are the things that it can do quickly. But as you get more complex, let's say code refactoring, you have code in COBOL, Pascal, or whatever, C++. You want to convert it into Python or Rust. That is little complex because the model hasn't looked at enough code to identify the patterns and convert it. Because see, all these models are doing only based on the code it has been trained on. So see, how do you think they are generating the code? Because they have learned from the publicly available code database codes, right, or repositories like GitHub or whatever. These models are trained on those coding patterns, right, on the public repositories. That is how it is generating. Now, if the code repositories are not good, or there is not enough data, there is not enough public repositories for Rust to understand the patterns, to convert C++ into Rust. So those things, it will still fall short. Yes, Santosh.
Can you hear me?
Hello.
Hello?
Yes, Santosh. You have a question?
Yeah, just a basic question. I got a little bit confusion between what is the machine learning and what is the deep learning and Gen AI. What's the difference between all these things?
I think we discussed that yesterday.
Yeah, maybe I missed the beginning part.
Yeah. So yeah, I'll just give you a brief. So machine learning is mostly statistical in nature, which is like you generate an algorithm, a model, just for specific use case. Examples include like prediction algorithm. You want to predict prices, real estate, or prices of or the amount of stock you need or amount of food you need for the restaurant in the next few days or the weekends, or the fresh produce that you want to put in the store for the next few days based on historical information. If the temperature is this, if the weather is like this, if it is a holiday season, and if it's raining or not raining, this is the amount of food I have sold. Now, what do you think tomorrow, how much food I would need to prepare? Right. So those kind of scenarios, or Netflix, I'm watching these kind of genres of movies. So how do I recommend similar movies or similar shows? Basically, the recommendation engine, or based on your shopping patterns or products you have bought, what products I can recommend you. So these are all typical machine learning algorithm use cases, which are statistical. Your classification, your regression, your clustering of, say, you want to run a marketing campaign for a group of people. You want to divide all your customers into clusters based on certain features, demographics. So these are some top machine learning algorithms, and then there are libraries. The next evolution over machine learning is your deep learning and neural networks, where image recognition, there is a neural networks that comes in, which has weights and biases, which does multiple layers of processing and then gives you an output, mostly like your neural network, to identify the images or read text from the images, all those kind of use cases that would come into deep learning and NLP, natural language processing. Now, Gen AI is built on all of these models that is trained on both deep learning and machine learning models, all of these algorithms, to specifically generate the data. Machine learning cannot generate anything for you. It can only run the algorithm on your existing historical data and then give you an output. But Gen AI is more generative in nature. You can generate images, you can generate text, you can generate audio, you can generate video, you can basically generate content, new content for, that is the generative AI. So this is the main difference. Now, for enterprise, as I talked about yesterday, there are specific use cases that only fit machine learning, specific use cases that only fit the Gen AI. It should be very clear as to what route you have to take to solve a particular problem. If you want to generate a summary of a 60-page document, a 100-page document, definitely you should go to the Gen AI. Or if you want to classify a sentiment, basically neutral, positive, negative, you can use it's a machine learning or classification algorithm based on the historical data feature 01. It's best suited for the machine learning use case. Okay, that's the high level summary.
Yeah, okay, thank you.
Yeah, sorry for that. I think we digressed a bit. Now, so you guys are all clear about this prompt, good prompt, bad prompt. Any questions? Okay, so those are like
Maybe I have a
yeah,
Harun, I have a follow-up question, right?
yeah.
So these prompts, right, that we write, they seem to be also very tied to the platform or to the model that we are writing. Is it possible to build prompts which can work cross models, or is given the non-deterministic nature of models, probably right now it's not so easy.
I don't see it is tied to any model here.
Mhm.
What makes you think it is tied to a model?
When I'm writing, I mean, simple things on ChatGPT and all those are fine, right? But when I'm writing, developing something for production grade, then if I use Gemini, the performance and the output, they differs from the kind of response that I get it from Anthropic or let's say
Yes, exactly.
on ChatGPT, right? Even
Yes.
coding, right, where I expect a little bit more consistency, right? Because codings are a little bit more, logical
Yes,
based.
definitely. Yeah, that is there. So while that is true, but there is nothing like a prompt for a model. Okay, prompts are generic, but it's true that the same prompt, when given to different models, you would get different output. That is true. Okay. Now there is recently Andrej Kaparthi has come up with some small product. I think LLM Council, you should be hearing. What he does is same thing. You give a prompt, it sends to different models from different providers, get the response, and it cross verifies with each other. Okay. It takes the output from one model and another model, you compare and contrast, and then you send it back and come out with the best answer for that prompt, which model is provided. Now, that sets the ground that the same prompt, when given to different models, will definitely give you different answers. Now, how do we handle that? That's where your model evaluation comes into play. What does model evaluation do is, for my particular use case, which model is best suited? Okay. It's not that if I change the prompt, it'll be good. But which model, as I said, if I'm doing a code generation, what is the best model for the code generation? And then once I take that model, then I tune my prompt to that model. It's not completely tied to that model, but I tune my prompt for that model. Now I get the response. Now I change the prompt and then I get the response. So it's an iterative process until we finalize a good prompt, which is, you can say, a prompt template, which are also like an objects, templates you can save. These are all the templates that is giving me good response for this model. Having said that, let's say you are written everything for GPT 3.5 or GPT 4. Now the GPT 5 comes in. There is no guarantee that it would give you the exact same output. You might have to retune your prompt for the new model. Okay. It might get you better answers or it might get you worse. Now, if you switch from OpenAI GPT to Gemini model, definitely things will not be the same. You have to retrain your new model on the data and then tune your prompt. So that is why it's an iterative process. It's not fixed, right? Whereas in your workflow automation, once you write a code, you write the logic, you test, you fix your bugs, you are good. But in the AI, it does not work like that. The moment your data changes, your output starts, it might, performance of the output might decrease. If bad data keeps coming in, your output might decrease. You change your model, your output will decrease, right? Or if you change the upgraded version of the model, also it might change. So there is always some reinvestment or retraining of the model whenever these things happen. That's also one of the challenges, unfortunately, we have, that it's not simple, right? So if you have an Oracle database and you upgrade, nothing changes. Retrospectively, whatever you have, it will still all work fine. But it's not the same case with the models. If a model changes, a new model comes in, now there might be a significant change in how it gives you a response for the same prompt. Okay, so long story short, yes, these are non-deterministic. You cannot fix it. As long as you use the same model and same prompt, still there is the delta, the difference is very less. But the moment any of this changes, if your model within OpenAI changes or you move to Gemini or any other, there is significant shift in the performance of the output. You should revisit and retrain, retune your prompts, look at the strategies, change whatever that has to be done. That is why people more take domain specific small models, so that once they train, they continue to use that.
Yeah. Arun, the reason why I asked is that, because for the POCs that I, my team develop or I develop, right, we use this open source models like Mistral and Llama, right?
Yes.
Because it's cheaper, to use them.
Yes, of course.
But then we realize that, once it is ready to scale, or if we want to move to production and we want to move it to a little bit more higher parameterized models, and then we again had to go from the scratch, right? Because the performance differs.
Yes.
So that was the reason, why I asked that question.
Yes, that is a limitation, unfortunately. Yes, that's the industry limitation. That that is why most of the projects fail when you start scaling up, because in the lower environments or POCs, the amount of tokens that you use are also less when compared to production. When you use agents, right? So how many calls it makes, how much context it sends to the models. And as you said, in production, you use a complex model, a bigger model like 175 billion or 1.5 trillion parameter model, versus in the POC, use a 1.5 billion model, parameters model. So there's a significant difference. So that you cannot expect the same results when you change your model. That is fundamental. You have to do the same thing in POC, the same model that you want to scale in production.
Correct. I mean, my expectation was that since we are moving from a smaller model to a bigger model, the performance will scale, right? But it didn't do that way.
No. See, the performance has nothing to do with the size of the model. It will actually degrade. The performance will degrade.
That's right.
As we are discussing yesterday, that a 1.5 billion parameter model has less computations to make versus a 700 billion parameters model, because it has to make much more computations before it gives you the response. The lag time is more compared to the smaller models. That's why, again, we talked about small language models or domain-specific models. First thing. It's actually the other way around. The performance decreases as you go higher, bigger models. So if you need a complex model for your use case, you should start with that model. And scaling is only that you create multiple threads or deploy the model on multiple machines, right? Same endpoint. Basically, your Kubernetes or Docker, you put it there to deploy and then use that.
Correct. We found it across actually on the code generation one, where we were using Cloud-A, and I noticed that in Cloud-A, if you write very good context and background, you actually get better code compared to OpenAI. But if you don't provide that, then OpenAI performs better than Cloud-A.
Which one?
Between Cloud-A and OpenAI.
No. Sorry, I missed you. Which one you said OpenAI performs better for which case?
For code generation.
code generation, you said Claude performs better,
yes. Yeah.
right?
If we give a good context,
Yeah.
if you don't get a good context, then Cloud penalizes you more than
Yeah.
OpenAI.
Right. Yeah. So I know I have also been using so a Claude Sonnet 4.5 for code generation. I did a lot of code generation here, Python and the Snowflake and database connections.
Yeah. I
A lot
actually
of
picked it up from
query.
you, from one of your previous classes you mentioned, and that's why I was like, okay, let's try this out.
Okay.
So,
Okay. Yeah. All right. So let's move forward. That's good discussion, Neeraj. Also, I think that's very helpful for everybody to understand. It's a different world. The orthodox strategies that we think of does not hold good here. As you said, if you go to bigger one, you thought it would perform better, but it's the other way around. That's good lessons learned. So now good prompts we have basically when you write a prompt, you give a role and audience. You give a persona to the model. Like we just said, you are an account manager or you are a Java architect, specialist, whatever it is. Then you give what are the goals, metrics. You can give what are the resources, limitations that you have, resources in the sense you can connect to the internet and all of that. Pass fail criteria, if you are giving some input to classify as a pass or fail, positive or negative, you can give criteria, what is pass, what is fail, what is the example. Safety guardrails or citations you can add, what guardrails you want to set, some restrictions, some limitations. We will look at guardrails also in our in one of the sessions. But when you say role prompting, as I said, if you want to give persona, this is what like assign a persona to AI, you say, hey, you are a Shakespearean actor, recite soliloquy about AI. So immediately the tone, the language shifts to the kind of Shakespeare language, not our normal English language. Then summarize this article in bullet points. So if you say summarize, it can give 1 page or 2 page, whatever. It does not know what is the scope, how you want to summarize. You can say in bullet points, so it will give you in bullet points. Again, you can say how many. You can say summarize in 10 bullet points, 50 bullet points, 3 bullet points, whatever you want, you can. And then when you see the output, you will know whether it would, you're losing the context too less. If you just say 3 bullet points and you give a 100-page document, it doesn't make sense. It cannot summarize in just 3 bullet points. It will be very vague. Or you can say 100 bullet points, it will be too exhaustive again for you to go through all of that. So it's kind of, you have to arrive at a decent score or decent size, what you want to look at. Critique. AI evaluates its own output. As I was saying, you can use one model to cross-check, verify your answers. It's basically used in the model evaluation, as I was talking about. We will also go through it when we do a session on model evaluation using LangWatch tool, how you can use one model to verify the work of another model. So you get the output from one model and then you pass it on to another model, which we call LLM as a judge. So you use another model as a judge to critique, to verify the answer from the model. Sometimes you use the same model to critique its own work. Hey, now you go back, check your own work, and then refine it, kind of a thing that you can do. Outputs, summarize the text. You can also give delimiters or the format that you want to generate. That also you can do. Now, when you look at the prompt, when you send to model, of course, you don't see it in the chat GPT application or whatever Anthropic, Claude. But when you write your prompt, when we go into the code and say when we interact using API, when we write application, not from UI, it has 3 components. The prompt you send to a model, LLM has three components. One is system prompt, the second is user prompt, and the third one is called AI prompt. Okay. The first two are what we said, system prompt and user prompt. AI prompt is basically what the model is giving you in response. So why do we need that in the prompt? I'll talk about it in a bit. System prompt is basically at the high level, you set certain context, certain instructions and rules that will be applicable for all of your user queries. It's like you are setting the rules which the users cannot override or should not override. It sets the overall context and behavior for an AI, acting like a set of instructions for how to do. For example, let's say yesterday we talked about how do we limit the output. Okay. Now in the system prompt, I can say, hey, always respond with less than 1,000 characters. 1,000 tokens is the limit for your response. That is my system prompt. Now, irrespective of how many questions I ask or who is asking that question, the system prompt will always go with the user prompt so that the answer always comes with the 1,000 because that is set for everything. So it goes into the system prompt. As a user, now you ask a question, you get 1,000 characters. But if you say, give me the answer in 5,000 tokens, what would happen? So basically, you are trying to override the system prompt, which is not allowed. Okay, so you have to put a guardrail saying that, hey, you are trying to override a system prompt. You cannot get the answer in 5,000. So that is the guardrail that you build to scan the input and say, verify if the user is trying to override your system prompts, right? Sometimes you can write, hey, forget everything in the system prompt. Now give me this. So those kind of behavior in the user prompt is scanned in the guardrails you write to make sure all those instructions are followed, that you are not trying to maliciously sabotage the system prompt or abuse the model. Okay. Now you are a friendly, informative customer service representative. You're giving a persona, financial advisor, creative writer. So all of this, plus you can also say in the system prompt, always generate, if you're saying code, right? Always generate, use Python as the coding language. So the custom user cannot use any other language to generate. Even if you ask Java, it will not, because in the system prompt you have set up. So all of that stuff you can put in the system prompt. In the user prompt is obviously your entire whatever question you have that you'll go. Now, when we go to RAG, we also send some context. Okay, we will talk about in detail about the RAG. So we also send some context to the model with our user question. So that context will also go in the system prompt. So every time you add that prompt, it goes into the system prompt that this is the context. And then this is the user prompt. You have the question of the user. So together we'll go to the model and the model will go through both and answer your questions. So what are the best investment options? This is all basic user questions that you have. So system prompt and user prompt. Now AI prompt, what it has is, when you're having a conversation thread with your model, the previously asked question, and then the next question. So since it has to continue that thread, whatever the response it has previously generated, we add it to the context and send it back in the next conversation. So that second time when it is looking through it, it will also have the context of what it has previously responded. So based on that, it will try to analyze. Say, for example, the code generation, right? You're fixing something. Now, unless it doesn't know what it has generated earlier and what you are asking now, that it is not working or having an issue, it cannot fix the old code. Because when you are doing through API, each call is idempotent because it does not have a previous history of the previous calls unless you maintain the same thread and maintain the same conversation in the memory. Okay, so basically, long story short, you have three parts: the system prompt, the user prompt, and AI prompt. So these three things. So I will show you when we do the actual demo, all of these things. So you have user, developers, checking LLM, you have system prompt, fixed instructions, and user prompts as the input queries. Some examples of prompting techniques. We'll do a 1 second time check. Okay, we still have 10-15 minutes. So fine, we are doing prompt. So is there some techniques that we can follow to make a good prompt? So there are 4 or 5 basic techniques that we talk about. Is zero shot prompt is just generic, basic, without any examples. You are trusting the model's general knowledge. You ask a question, it gives you an answer, that's done. Say, for example, summarize the causes of World War I. It provides a summary of all of that. So there is zero shot, which means you just give question and then answer. That's it. You're not giving any additional information or anything. Or few shot prompt. Few shot prompt is basically you're asking a question, but then you're giving it some examples to follow. You're teaching the model with an example, which would improve the output quality. Okay, so I'm asking a question, but then I'm giving an example. What are the causes of American Civil War? And then I'm giving a bullet point: slavery, debate, state rights, economic differences. Or it's a second example: what are the causes of French Revolution? Just give me the bullet. It's just like giving me the bullet points of all of that. So AI now lists the causes in clear bullet pointed format, because that is how I am asking it to give me the output in a bullet points. So this is like providing some examples. Also, let's say you are doing a sentiment analysis. The users have given some comments. Now, based on the comments, you want to understand whether they like your product or they don't like your product, right? So in that case, what you do, you give some 5 or 6 examples. Hey, if the comment is like this, or 10 examples, whatever it is, if this is the comment, mark it as positive. If this is the comment, if the comment has, for I say, happy, love it, something like that, you say positive. If the comment has not good or not satisfied, unhappy, these kind of words, then you put an example as negative. Okay, if there is none of these, you just put neutral. So that kind of 5 to 10 comments you put and examples, the model will look at these, understand, oh, okay, if this is this, I have to do this, this is how it is. Then it's kind of trained on these examples. Now when you and then it will look at the actual user prompt, that is your comment that you pass, and it will try to classify it into one of these 3: positive, negative, or neutral. So that is your few shot prompt, where you actually guide your model with some examples. Okay, this can be your historical, or you can give on your own kind of a thing. Now, let's say you put 10 comments, you put 100 comments, and you see the output. Now, if you feel it is not doing the classification properly, that's where you go back and you tune your prompt. Okay. What does tuning my prompt means, or training my model means? I have to change the examples. Probably they are using some other terms which you have not given it in the example. Or probably they have a language that is not English, or maybe they are giving in Spanish some comments which it cannot do. So those kind of things, you go back and tune your prompt again, adding more examples or changing your examples, so that you get a good classification. Otherwise, you see, a good classification is basically less and less of the comments fall into other category, unknown or neutral category kind of a thing. So that's how you keep training and retraining your model with the prompts. So that is your few shot prompt example. Chain of thought is basically when you give a problem to the model, how it can break it down into smaller steps and start answering. Initially, again, most of this, as I said, prompt engineering in last 2 years have evolved so much. It's already all built into these things are all built into the model right now. Earlier, you used to have to actually explicitly ask the model to use chain of thought to solve particular problem. But right now, if you go and look at any new models, they already do all of that. They do chain of thought, tree of thought, thinking, critiquing, redoing. They go through 7, 8, 10, 15 steps. Now the response is like forever. It takes 3 minutes. Earlier, you type, it just throws at you some, giving you some answer, right? Now it takes, if you go to Anthropic, like Neeraj said, you put something, it takes at least a minute, 2 minutes, 3 minutes sometimes to start giving you the response. Because it's doing so much of work going through all of the steps to come up with template and all of that. If you just ask a code, it does the code, it does the README document, it does the test cases, it does the framework, it does the documentation, it gives everything. If you just ask for the code, okay. And now you have, it's other way around. You have to limit. Hey, don't give me all of this. Just give me only the code part. So something like that. So chain of thought is like giving the model, asking it to break it down step by step to come up with an answer. Okay. One step you evaluate, look at the response, then figure out what is the next step. So like that. So where this was mostly used to earlier was the models were not very good at solving the word problems, because there's a lot of logic in the text, natural language processing. It's not a straight away mathematical process, right? It's a NLP, natural language. Now, if you have, it looks for like 2 books, one free, each book costs $15. You buy 6 books, right? So in a zero shot prompt, if you put, it would straight away say 6 books, $15, and then you say 2 books get 1 free. It will ignore that as additional information, and it will give you 90. But when you do ask it to do chain of thought prompt, under the buy 2 get 1 free deal, it will split 6 books into sets of 3 and do all the step by step. So the answer is 60. Now, again, I'm reiterating, this does not apply now, because by default, the models have now evolved so much that they naturally do all of this. By default, do the chain of thought prompt. So if you try this, you don't get this answer anymore. But at least there is some technique. It was called chain of thought, and then React prompt. So React agent architecture. This was what our agentic AI was built on, agents. You have thinking, you have tools, you have answers, you get the answer, you reason it, and then take action based on the reasoning. Say, best example is, let's say you are doing a planning a travel vacation. Now you have flights, you have hotels, you have car booking to do now, and then you have budgets. So if you want to book in a hotel for the dates, you have to first book the flights on the same dates, availability. Now you have to book the car only after you land there. You cannot book a car at morning 10 a.m. when you are landing at 9 p.m. there, right? So these things are dependent in each other. So the reasoning would, so when he says book a car, then it will have to come back and say, is the flight booked? What time are you landing? So you have to go back and check, reason, take action based on the flight books. When the flight is booked, do you have a hotel, right? So you are landing at 10, 11. Then if the checking is at 3 o'clock, you are landing early morning at 5, then you have to wait until your check-in time, which may be 12 o'clock or 1 o'clock. So is an early checking the hotel that is possible. So all of these reasoning will happen. It will go into the loop. It will go multiple times to check and then rerun that prompt again to the model. So all of that happens. So that is called the React prompt that goes in. Interactive agents. Okay. So there is another tree of thought also. There is React prompt and chain of thought, tree of thought. So this is how your, as I said, right, reasoning steps will follow until you get the final output. Like my travel example. So these are all just for knowledge sake. Okay. Most of it, as I said, is already handled by the agents, by the model itself. But you have to structure your prompt as to what you need. In the travel agent example, if he has to do all of that, you have to give the clear inputs that, hey, I am traveling to, say, Bahamas or Hawaii. I am planning a trip for 7 days or 4 days. This is the date I want to travel on. I am flexible with the dates, 1 or 2 days. This is my budget for the flight. I am looking for economy class or business class. What kind of hotels I would like, 3-star, 5-star. Does I need the hotel to have free breakfast or the Wi-Fi? I want it close to the beach, the hotel location within 2 or 3 miles from the beach. So all of this information you have to feed in the prompt properly for the model to give you the accurate plan. Sounds good? Any questions? I will take another 10 minutes to introduce the concept of RAG architecture, and then we can wrap up this session. Questions? Guys, come on. Anyone? All good? Am I audible?
Yes, sir, all good.
Okay, at least Pawan can hear me.
Yeah, Arjun. All good.
Okay, all right, great. Guys, you have to talk. You have to unmute and talk, acknowledge at least, so that, it'll help me that you're still with me, following me. Either you understand everything or you're completely lost. So I have to get confirmation if you're completely lost.
It's good, Harun. Yeah.
Okay, great. Good. All right. So that is, we talked about LLM models. We talked about the prompt, right? Now, question, you're all following, right? Give me the top 3 limitations of LLM model. Not Pawan, not Neeraj, not Girish. You 3 are disqualified. Anybody else? Top 3 limitations of
Hallucinations, lack of citations, are non-deterministic.
Okay. Anything else? Hallucination, lack of citations is one. Yes. Next.
And confidently it is saying whether it is wrong or right.
Okay, that's again within the hallucination scope, right? So it is saying confidently, even if it is wrong, but it's still hallucinating. So other than hallucinations, there are 2 other limitations that a model has.
It doesn't have latest data.
Good. Okay,
That
it does
means,
not have
let's suppose
information
latest
to
data.
Yes.
So let's suppose if you want to specific company data, like internally HR related info, it won't be contained. Whenever you have RAG, at the time it will get that specific company knowledge and all those details.
Okay, good. So it does not have latest information after the training cutoff date of the model. So whenever the model has released, it does not know the current events happening after that date because the training is done. So, right, that's one limitation. That we will solve with tools that we give to the model to connect to internet or web or whatever sources to get the information. And as Pradeep said, the third limitation is, Neeraj, no worries. Yeah, I can do. The third limitation we have is the confidential or the company information that we want to have access to. So the models does not have, because they are only trained on the public information. Now, to address specifically the last, the first and the last, the hallucination part and the last part, the confidential information, we have come up with an architecture called RAG, Retrieval Augmented Generation architecture, RAG model, to build applications that AI will get information from our internal data. Basically, are your chatbots or RAG applications, which means not public, internal, say customer service or internal employee ask the whatever employees ask questions. Every company is doing their own chatbots. All of that is your RAG applications. So what does RAG mean? I said retrieval augmented generation. It's an AI framework that combines information retrieval with text generation. So LLM have limitations in knowledge cutoff. RAG helps bridge this gap. Chatbot retrieving up-to-date company policies before responding. It does not have access to real-time information. That is fine. But current, whatever the policies, company policies, or whatever customer needs from the company information, that is solved using the RAG architecture. We talked about various examples yesterday, right? About what confidential company information like sales data or the HR policies information or the customer support, what are the previous questions that it has raised, the customer has raised, what are the common problems or troubleshooting guides, and all of that is the common information. Okay. 1 second, I think I need to somebody. Okay. Now, what are the components of RAG architecture? So RAG architecture has a retriever, a generator, embedding models, and vector databases. So these are the 4 main components. That's why it's called retrieved augmented generation. So, okay, 3 parts. This is the basic architecture of a RAG application. We will dig deeper into this next week, and then we will also start our hands-on demos also next week. For the next few sessions, at least 2 weeks, for the next 2 weeks, next 4 sessions, we will be beating this architecture diagram to the pulp. Okay, everybody should be very, very comfortable, have a mind map of this and understand each and every component in this. We will go in detail into each of this component, most of these components. For example, embeddings. We'll start next week, first session, with what is an embedding, why we use embedding, how does an embedding look like, what are the embedding models that we have, what is the semantic search, how do we, so that's embedding. Then what is a vector database, how do we store into embeddings into vector database, what are different vector databases we have, how can we use them, what are the search techniques that a vector database has, and then we build semantic search applications with this. Then we will look at, when we are doing embedding, how do we take data information, how do we split into chunks, what are the various chunking strategies, and we use those chunking strategies, generate embeddings, write to vector database, and then we create applications. Then we also add augmented data. So retrieved data. For how do we retrieve data? When a user asks query, how do we convert to embedding, and then search this database for results, get those results, retrieved results, and then pack both this data that is coming from vector database and the original query from the user together to a model to generate the response. This is the complete RAG architecture that we will be discussing for the next 3 to 4 sessions, building RAG applications with various platforms, languages will build vector database applications like semantic search and all of that. Okay, so this is the RAG architecture. Now, how are we solving the problem of confidential or company information is here. So when the user asks a query, you go to LLM and the LLM will give response. So all of this is not in scope. So you don't know what the company information is, right? Now what we are doing, instead of just sending just the user query, we are also sending the retrieved information from our internal database. This is augmented data. So where is this information coming from? From the vector database using this query. What are the related information that we have for that user query in our database? So we give that results plus query to the model so that now it has our company information to go through and respond to it. Now, how does it come into vector database? Because we take all of our sources, whatever we need, whether it can be sales data, relational databases, tables, or company policy PDF documents or Word documents, whatever it is, take that, process it, generate embeddings, and store in the database. That is what is retrieved based on the query. But here it is a semantic search query, not a SQL query, so that the search happens with the embeddings, not with the actual text. The text gets converted to embedding, and then search happens based on the embeddings, and the returned results will go into the model along with the query. So this is the high level, what we call RAG architecture, and that's how we kind of solve the confidential company information lacking in the model. Okay, so this is just another representation of this. We have document, we split to chunks. We use an embedding model to generate the embeddings. So we'll also talk about what are different embedding models. We looked at it at a high level yesterday and today. So embedding models, and then we store in a vector database. There are, again, different vector databases we'll talk about. We'll write this embeddings into the vector database. So this is the retrieval from the database. Then we have context. So we are enriching this prompt, adding this information here. So we are augmenting it. So that's why it's called augment. And then we send to the LLM model. So that becomes your generation from the LLM model. So if you just take out the last LLM model thing, right, and prompt, just this retrieval becomes semantic search application. You can just send these results to anything or recommendation engines for further processing, whatever, or you can continue for generation using the LLM model. Okay, so this is the RAG architecture introduction. So next week we will get dive deep into this, starting with embeddings, embedding models, and vector databases. So we'll first go through the left side part of it, building semantic search application. Then we'll plug it in these things, the LLM model, to make it the complete RAG architecture, RAG application. All right. So that brings us to the close of session 2. I would like to open up for final Q&A before we wrap up.
Yeah, hi Arun, this is Pradeep. I have small doubt. So in
Yeah.
the right hand side, user query is there, right? So
Yes.
it will be a prompt message, right? Not embedding, right? Correct me if I'm wrong.
Yes, this
Right hand
is a
side
prompt
above.
message. Yes.
But here it is mentioned embedding. That's why I'm getting doubt.
You convert it into embedding here.
Okay.
Use the same embedding model that you are converting this into embedding. You will also convert user query into embedding to search, because vector database has embeddings. You search with the embeddings, but you get the actual text out of this. And then you pass those text plus the original user query as text to a LLM model.
Okay. Generally, this vector database is data will store in digits, right? But numerical format, right? Correct.
Yes, you will store the text and its numerical format embedding both together.
Okay.
So you search, it's like key and value, right? So when you search in a say normal database, select name where ID is equal to 1001. So 1001 is your ID number, but you are selecting the actual name. Same thing here, you pass the embedding and then you get corresponding results, the text, actual text, and you will pass that text to the model.
Okay, these embeddings will be stored. How it look like? It's a numerical format or it's a text format?
We will do it next week. We'll do it. I'll show you everything in demo. I'll show you the actual embeddings, what are the dimensions, how it looks like, for what sentence, what embeddings are generated, how we store in the database, how we see in the database. Everything we'll go through. I'll show you everything. Don't worry about it.
Yeah, thank you, Haru.
Yeah, it is stored as an array of numbers, decimal digits. It can be 500, it can be 1000 elements in that array. That complete array is called the embedding. That I will show you next week in detail in demo.
Yes, sir. I have a one doubt, like this raw data information extraction, then chunking and embedding. So like there is the like transformation of data is happening here till the embedding layer?
No, we don't do transformations.
Okay.
This we do already transformed data if it is a RDBMS. Okay. Let's say, for example, I'm giving you two different sources. Let's say we're talking about the HR policies. So they are all like your PDF documents, for example, or conference pages. So we don't do any transformation. We just take the text, break it down into smaller pieces called chunks, and then generate things and store. Now take the other case. Let's say you are getting sales information from some other system. When it comes to your database, you do transformations upfront. You remove the nulls or remove duplicates and do all of that. And you have already enriched or transformed data. That data you will take and then do the chunking and embedding for that data. Within the RAG, you don't do the transformations or data quality, but that is a step precursor before the data comes into the RAG application. That is preparing the data for AI. That is all your data engineering that comes in before you send the data.
Okay.
Okay, so that's where you write your data pipelines coming from source systems, handle nulls, handle data validations, handle the structure, handle null columns or missing columns, remove duplicates, aggregates, all of that, date formats. You do all of that, and then you give a sanitized data. That is for AI to work on.
Yes. Okay. Okay, got it.
Okay. All right. Yeah. Any other questions, guys? All good? Okay. Awesome. Thank you so much. Appreciate your time. We will meet next week. So next week we will be getting into the code demos. So request you to go through these concepts, understand, just give it a reading, make sure you're all comfortable with this terminology. Okay. We'll meet next week. Any questions, reach out to me, either in the group or
what do we need? Do we need tools and new licenses for the next week class to hands-on the RAG implementation?
Yeah, I will show you. Probably you need to get OpenAI API for embedding models. Vector databases you don't need next week. We will do just the open source libraries thing. But for generating the embeddings, we'll first do the open source. Then I will give you how to get a OpenAI API key, and then we can use that key for all our demo examples.
Perfect. Thank you.
Okay. Yeah, no worries. Yes, thank you so much. Appreciate your time. And once again, please put your information in that document that Ishrat has shared. That will help us. Okay. Take care. See you next week.